Hi, my name's Keith Cooper, Northlight Images, and in this video I'm going to have a look at some recent patents from Canon about tilt-shift lenses and various aspects of tilt-shift and cameras. You may have seen some mention in sort of news sites about things decrying the end of tilt-shift lenses as we know it. Basically, all those articles do is reveal the lack of knowledge of how tilt-shift lenses work by the people who wrote them. Here, write me 500 words on something like this with a catchy title. Fundamentals of tilt-shift lenses. I'm going to go through some stuff here which I hope is of interest. I did ask the other day if anybody got any questions on using tilt-shift lenses and what it's about, what it really means from a how things work point of view. Now, standard tilt-shift lens, here we are. This is a TT Artisan 100. It's a macro lens, and that is the tilt. As you see, the lens just tilts backwards and forwards. A little bit too freely in this one, but now the shift as well. But I'm just going to have a look really here at tilt, because this is the bit that people generally don't understand quite what it does. And it means that a lot of people, when they get tilt lenses or tilt shift lenses, they mess around with the tilt, they tweak the settings, they think, well, there's a few things it's doing it, but there's nothing ties it together. Now, that's one of the reasons I wrote the book on tilt-shift lenses, how to use them. Covers all of this, and I've got lots of articles, I've got lots of videos about it. But this is about some of this new stuff, some of these new patents. Now, tilt-shift been around for a long while. Here we have my old MPP 5x4 camera, or 4x5, I believe, to those of you in North America. But this is the viewing screen on the back, where you focus. You've also got adjustments all over the place. The film goes in here. You pull this forward, it goes in there, and you take the picture. There's the release for the shutter. We've got all the various movements. Now, you can see here that I can tilt the front, just release that lock. I can tilt the lens there. Let's just do, there we go. I don't use this very much, haven't used it for a long while. In fact, that's one of the times I used it. I made an adapter to put a DSLR on the back in place of this. But anyway, there's lens tilt with this, same as lens tilt with this. So that's the basic of it. Now, there are lots of other things as well. Let's just start off with this patent that's been doing the rounds. It shows an example, and remember, patents only are there to show ideas and examples of ideas. They're written in a very formal way. They are not meant to be readable. I put links to a whole load of US patents, so you haven't at least got to look at, this is a Japanese one. The Japanese ones, you've got the vagaries of translation as well, but the US patents are difficult enough to read. Now, I put links to all of those in the notes here. The patent here shows a camera device, and this is quite often all you get in these. It is a device where the sensor tilts. So rather than having the lens tilt, as this one does here, let's just put that back up like that, we've got the sensor tilting. Now, this particular design, you can't tilt the sensor like that. You end up needing to do the whole thing. So it moves back. This is why you have it mounted on a very hefty tripod, and there we go. We've got sensor tilt. Now let's just move that in there so it's a bit better. So we've now got a tilted sensor. Is that the same as tilting the lens? Not quite. Now, depending on how complex you want to get into using such things, and remember, I wrote the book deliberately from the point of view of people wanting to use lenses like this, not contraptions like this. The two are quite different in how you go about things. But tilting the sensor like this does give you the tilt effect. You can see that they're similar. I could actually do both. I can do that as well. And so I've got tilt to the front, tilt to the back. It's quite complex setting up cameras like this, and as I say, it was because of that complexity was really the reason I decided to write the book about how to use these, not this. Now, what can we say about this patent that people are saying shows the end of tilt-shift lenses as such? It shows a mechanism for tilting the sensor. If you look in details of the mechanism, you can see there is a worm drive, there are gears, and there's a giant great spring holding things in place. This is not the equivalent of your IS type unit, the image stabilizing unit on the sensor of cameras. This is something big and clunky, and it is used for adjusting the tilt of that. This is almost certainly aimed at the likes of security cameras. Why security cameras? Because let's say you're looking along a street, you don't want your plane of focus necessarily at one point. It would be nice if the plane of focus ran along the street so that people all the way along the street were in focus. In fact, lots of Canon's patents, if you go through them, lots of them do show applications which are pretty obviously security cameras. This mechanism here is simply not practical for an actual camera that you might use. It's about as easy for this to do stuff rapidly as it is for this. It's just not made for that. So that's that patent there. So it does not signify the end, it just shows use of sensor tilt. Now sensor tilt, yeah, security cameras, we're not seeing it, but Canon has lots more patents of it. As I said, list these, go through them, and read the text of them. You'll realize how difficult it is. There's lots of stuff. Now these get very mathematical quite quickly. A basic one here includes a tiltable sensor. Once again, it's similar to the one we've seen, whereas the one we've seen just earlier has a mechanism for tilting the sensor. This one just has a box that says tilt control unit. It's looking at different aspects. Remember, patents don't just... A patent is not a product. A patent is a particular idea and areas where that idea might be used. The patent is there to protect that idea and its potential use, and that's why they're written the way they are. So we've got this particular one here. So that's a patent looking at that. But what about actual lenses? Now it turns out there are some patents for lenses with tilt and shift in them, but where they don't do this to do the tilt, nor do they do anything like this. They move the internal elements of the lens. Now this is quite tricky. Whereas tilt with something like this, I can say, look, the lens has been tilted 8 degrees vertically like this. And I can look up in tables and I can see the effects of tilting at 8 degrees. That's relatively easy to do. It's quite straightforward using these things once you've got the knack of it. But in this particular design, it is using off-centered lens elements. How does that work? Well, trusty magnifying glasses. The normal thing of focusing an image, and I haven't got anything set up here to actually show you this, but I'm focusing an image of something. A simple lens. Now, simple lenses, the maths are much easier. Once you get to actual lenses with lots of elements in them, the maths becomes more complex. And perhaps that's why we're only now seeing lenses like this in patents, because it's now the computational optics that can be done on the designs enables this sort of lens design to be done. So basic lens like that, you focus your image like that. Lens tilt is quite simple, it's doing that. If you've got a magnifying glass like this, by the way, a sheet of cardboard, try it out. Focus on a scene and then tilt the lens and see how the plane of focus changes. It's a really simple illustration of how lens tilt works. Shift also, because in shifting, when I do this with my hand, I can see the image of the light moving up and down on my hand here. That's lens shift. It really is as simple as that. This particular example, though, has multiple lens elements. And in this, it's using, rather than tilting the lenses like this, it's using off-centering other lens elements in the design. So the lens is moving up and down like that. And that's giving us tilt effects and shift effects. The precise mix of tilt and shift effects are really quite complex to work out. What does this mean? It means Canon can actually, and whether they do or not is another matter, and you can assume that if Canon are doing this, other people are doing it as well. It's possible to come up with lens designs, and here is a nice complex lens design where you can see there are two elements. Now, one of the elements is a positive lens like this, and another element is a negative lens, and the movements of the two of them give combinations of tilt and shift. Now, that's one design. there's another design. There's a whole load of example designs, and so these are in the patents if you want. But interestingly enough, whereas I tend to use tilt shift lenses, mainly shift at wider angles for architectural work, these lenses are quite long. The examples given, there's a 300mm f4 lens with tilt and shift. Now, tilt and shift on a 300mm tilt, why would that be there? And there's a 100mm example, 180mm example. They're all long lenses. So these are not tilt shift lenses like your TSE 1724, Nikon PCE 2419. These are not ones like that. These are long lenses. What might they be wanting to do? Well, if you read through the patents, you can see that there is the idea of using lens tilt by this mechanism to shift the plane of focus. Now, the plane of focus with a 300mm lens at some distance when you're looking at something is quite thin, certainly if it's f4. A bit of tilt would allow you to tilt and move the image plane just a bit, and if this is under full automatic control, and it is, because this is operated by similar mechanisms to the image stabilization in lenses, it allows you potentially to flip your plane of focus a bit when you're focused. I'm thinking of an example of, let's say you're looking at 2 or 3 footballers in a distance in the middle of a game. It allows you to rapidly move the plane of focus. Now, if you tie this in with face detect, you can have it so that your system is automatically tracking the plane of focus on faces that you want. So rather than having one face sharp and a person behind them blurred, you could have both sharp. Now, I don't do sports photography, so I have no idea how useful this would be. I don't watch football at all, so I've no idea what this would do. But I can see all the possibilities for something like this, and that is using a lens like that and just moving it. Now, you think, what about real lenses? Well, there's another patent, has an example of the construction of a real lens. Now, that looks quite a wide-ish lens. The obvious look of the front element on it suggests a wider lens. Are we going to see replacements for the TSE 24, TSE 17 for RF mount with internal shifting and tilting like that, using lens elements, just doing that? I don't know. A problem that I can see is that how do you actually make this easy to use? And there are patents that look of ease at how you can produce an interface for such things as well. So there you have it. The patents that's been widely shown, which is the one of the mechanism, is hefty and I mean, it's got gears in it to move the sensor, and it only moves it in one axis. So it's not that. This is more like this than any smaller camera that you might use. All the principles of tilt and shift, though, are there in this. In fact, the reason I built this adapter years ago was to experiment with tilt and shift. Now, this has got a 150mm lens on, which is a bit long for doing this, but with an adapter on the back of it, you can get quite a nice feel for how movements work. And you can see things like the difference between, let's say this is where I said, the difference between moving the rear element, the front element, actually tilting things. So the whole mechanism just tilting like that. All sorts of differences. So you can, yeah, it looks impressive. I must admit, when I had this out on the street, when I was testing it, I had quite a few people come up and look at it and wonder what I was doing and that. And then wish they'd not asked what it was doing. The explanation was a little long. But there you go. That is tilt and shift. That's some of the patents. If you're interested in stuff, do have a look at the notes, because I got links to the actual patents, the US ones, which are PDF links, so you can see the actual stuff on that. But as I said in the other video, if you've got any questions, more practical questions on the use of tilt and shift, and I'm going to be doing a few more things on this, and I'd love to make a good example with magnifying glasses as well. But anyway, I hope that was of some interest, and thanks for watching.